Okay, we'll be talking about atomic mass and isotopes today. So I guess we'll start with saying the atomic mass, its definition is it's the mass of an atom in atomic mass units. Now, what is an atomic mass unit? Well, first, you'll just mention that it's basically about the mass. It's about equal to the mass of a proton or a neutron. Of course, an electron, you know, is about 2,000 times smaller in mass than the mass of a proton or neutron, so it's much, much smaller in atomic mass units. But actually, the formal definition of an atomic mass unit is it's 1/12 the mass of a carbon-12 isotope or atom. And so we can then say that if you have an entire carbon-12 atom, then you'll have exactly 12.00 atomic mass units. What about the mass of a hydrogen-1 atom? Would that be 1.00 atomic mass units? No. You can't just shuttle this number over exactly. Oftentimes there's slight variations in the atomic mass. And so actually the atomic mass of a hydrogen 1 atom is actually 1.008 atomic mass units. And so you'll find, though, that with our carbon-12, this 12.00 atomic mass units, we don't actually find that number on the periodic table. The periodic table shows 12.01. And so why is this number different, even though this 12.00 is an exact number? Well, the number that we report on the periodic table is the average atomic mass. It is a weighted average of all the naturally occurring isotopes of that element as they're found on Earth, in the percentages that, and considering the percentages that they're found on Earth. And so, how do we know the percentages of one element on Earth versus another? Well, we can study those by using mass spectroscopy. Mass spectroscopy, it will analyze the percentages and masses of constituents of a mixture. Or later, after you get into organic chemistry, etc., you'll find mass spectroscopy can also be used to break down large molecules into small parts and will allow you to determine the masses of those small parts and the percentages of those and allow you to get a lot of information about a certain molecule. And so let's say that we were to analyze carbon-12 using a mass spectrometer. We might get a graph of the intensity of peaks versus atomic mass. Because we're able to separate isotopes based upon their mass, the different locations that these different isotopes hit might be hit in different kind of amounts. So, for example, there's going to be a large reading at 12 atomic mass units and a small reading at carbon-13 and a very, very, very small reading at carbon-14 or 14 atomic mass units. And that's because we're going to have primarily carbon-12. In fact, you should, if you run a spectrometry of carbon, you'll get that 98.89% of all carbon on Earth is carbon-12. And you'll find that 1.10% of all carbon on Earth is carbon-13, and carbon-14, well, that's much smaller. It's 0.000000001% carbon-14. Now, just by the way, I want to mention, what do these numbers mean, this 12 and this 6? Well, this 6, remember, is our atomic number. So that is just the number of protons. This 12 is the mass number. So this is the number of protons plus neutrons. So how many neutrons are in a carbon-12 isotope? Well, it's just the difference between these, 12 and 6. So there are 6 neutrons in carbon-12. How many neutrons are in a carbon-14? Well, the difference between 14 and 6 is 8, right? So there's 8 neutrons in that. There are 7 neutrons in carbon-13. Okay, so continuing on, we've learned that the vast majority of the carbon on Earth is actually carbon-12. And so when we calculate for the average atomic mass, we'll be using an equation which accounts for the percentage of all of that element that is this certain isotope. And so this is kind of a general equation, the percentage of that isotope times the mass of that isotope, and then combined with the percentages of the other isotopes times the masses of those isotopes, all divided by 100%. And so in our case, we've got 98.89% of carbon is carbon-12, and multiply by that by the mass of carbon-12, and then also consider that 1.10% of carbon on Earth is carbon-13, and its mass is actually 13.00335 atomic mass units. And then I'm not going to include the carbon-14 because it's so infinitesimally small as a percentage of all carbon on Earth. Divide by 100%, and then we get that our average atomic mass is 12.01. Now, you will note that because the vast majority of carbon on Earth is actually carbon-12, that the average atomic mass of carbon on Earth then is much closer to 12 than to carbon-13. And we'll be watching a video about how to do further calculations with regard to that next.